Okay, so we are interested in determining the direction of the cross product, but before that, let us try to understand what we mean by a right-handed coordinate system. Here I have drawn the standard coordinate system, but what do we mean by the right-handed coordinate system? It simply means this, that when I have my fingers towards the x-axis like this, and my hand is like this, so for all of you to see, I point my fingers towards the x-axis and I curl them towards the y-axis, and you see that my thumb point towards the positive z direction. Okay, but if we had the opposite case, if I had my fingers towards the y-axis and I would have curled my finger towards the x-axis, then my thumb would have pointed towards the negative z direction. Now here you cannot see the negative z direction in this way because I have curled my fingers in the wrong direction. So if this is the y-axis and I curl it along the x towards the x direction, you see that my thumb is pointing towards the negative z direction. So in this case, I point my fingers, this is my hand, I point my fingers towards the x-axis, I curl them towards the y-axis, I curl them towards the y-axis, my thumb points upwards. Okay, that is the reason why in this particular scenario the z-axis will be coming out of the plane of the paper. If I point my fingers towards the y direction and I curl my fingers towards the x direction, then the thumb points vertically downwards. That is the reason the z axis will be going vertically downwards in this particular coordinate system. Now we are talking about the cross product, the direction of the cross product. It works exactly in the same way. So if I am talking about a cross b, I have to point my fingers towards the vector a, curl my fingers towards vector b. I'm curling my fingers towards vector b and my thumb points in the direction that is perpendicular to the plane of a and b and towards the top. Therefore, in this particular case, a cross b vector, which had that magnitude ab sine theta, is going to come out of the plane of paper. But if we are talking about b cross a, I point my fingers towards the vector b and I curl my fingers towards vector a. I'm going to make it more, I'm going to point the things more beautifully. I point my fingers towards vector b, all my fingers towards vector b, and I curl my fingers towards vector a. And you see that my thumb points vertically downwards. As a result, what will happen is that the cross product b cross a is going to point downwards, that is into the plane of the paper. So that is how you find out the direction of the dot product and the direction of the cross product. I'm sorry, dot product doesn't have a direction, it's a scalar, right? So that is how you find the direction of the cross product in elementary physics classes. Later on, you are also going to have some other techniques that you can use to save you from this tantrum of pointing at directions and all. Okay.